Hello students, welcome to class 12th. Now today we are going to start with your physics course. Now if you know that we have got 14 chapters in physics and these are on different units. The first unit we are going to start with is about electrostatics. In electrostatics we have two chapters. The first one is electric charges and fields and the second one is electrostatic potential and capacitance. So here we are going to start with the first chapter, that is electric charges and fields. So let's start with it and see what important points are there in this chapter. Okay, now it's a very common experience that when we rub a dry comb against our hair and keep it near small bits of paper, the paper pieces will get attracted to it. Okay, it's very common. I am sure that you must have done this activity many a times. Now in this image you can see that when the balloon gets rubbed against the hair of the boy, the hair strands are attracted towards the balloon. You know that there are many such simple examples in our daily life which are based on these kind of observations. Now the obvious question is, why does the balloon attract the boy's hairs after being rubbed? Okay, again if I ask you why the bits of paper get attracted towards the charged comb or rod, okay, what is the reason for that? Now all these instances can be explained by a simple term. The term is charge. Now you can see here the hair strands standing up gives a very common feeling, no? Center shock, right? So whenever we you have seen in the ads that whenever the person like touches anything, okay, in an electrical device or not, he gets a shock and all the hair strands just stand up. So this is the thing. So we can say that the balloon was charged and due to the presence of charge it was able to attract. So now the obvious question is, what is the meaning of charge? So let us try to find out what does charge mean in general. Okay, so one thing is for sure, we saw in just the last experiment, last slide, that whenever there is charge, the body can attract another body. You have learned in your earlier classes that two charged bodies can repel each other as well. So if you summarize, we can say that what is charge? Basically, charge is a property associated with matter. Obviously, matter has charge. Like, you know, electrons are charged particles, protons are charged particles, they have charge, right? So it is associated with matter by virtue of which it can interact electromagnetically. What does it mean? That means it can exert or respond electrical forces, it can get attracted, it can get repelled, or it can produce magnetic effects, or it can respond to magnetic effects. About this we'll learn in the subsequent chapters. So basically in this chapter we'll see that what will happen if the charges are at rest, right? So charge is a property by virtue of which the substance or the particle or the object can interact electromagnetically. Now basically in the branch electricity we discuss about, or we learn about charges, what charges can do, what are their characteristics, etc., etc. Now the whole branch of electricity can be divided into two parts. The first one is called electrostatics, that stands for the phenomena due to charges at rest that we are learning here. And the second one is called electrodynamics, where we study about charges in motion. Now this electrodynamics is a very broad section in which we have current, electricity, magnetic effects of current, then electromagnetism, and many chapters are there that will come across one by one. So basically here we are learning about electrostatics or charges at rest. Okay, now coming to the next part, types of charges. Now as we were discussing in the last slide, that, or prior to that, that whenever we rub a piece of say a glass rod or a dry hair comb with our hair, or with a silk cloth or a fur, then it can attract small pieces of paper. That means it has got charged, or we say that it has got electrified. Now you have learned that earlier you have learned that there are positive charges and negative charges. So why it is positive or negative? So basically the experiment was tried out with different varieties of substances, many kinds of things, different experiments were done, like combining the different pairs, which one is attracting, which one is repelling, etc. And it was found that basically we have two varieties of charges. Now Benjamin Franklin, he named these varieties as positive or negative. Now remember, these positive and negative terms are simply by convention. These are not mathematical, but we will see that we characterize charge as per these positive charges or negative charges. So we can say that there are two varieties of charges. One is called positive and the other variety is called negative. Now this being positive or being negative is sometimes called polarity of the charge, that whether the charge is plus or it is minus. Now by convention given by different scientists, okay, it was said that if you rub a glass rod with a piece of silk cloth, obviously, so it will get charged, both will get charged. Now the charge on the glass rod will call it as positive and the charge on the silk cloth will call it as negative. And likewise, by comparing these things with the other, we could find out the nature of charges of different objects and particles. Like you know that electron has negative charge, proton has positive charge. So all these are simply by conventions. Now in the last segment, if you remember, in the last slides, we have discussed about what is a charge and what are the types of charges. That means how to identify whether the object is charged or not. Now, whenever we are discussing about charges, we are dealing with charged objects, we have to understand some important properties of the charges. Now, what are these properties? The first one you can see is called additivity of charges. Okay, so what is the meaning of additivity? That means that if I have a system in which there are many charged particles or a system having a cluster of charges, then the total charge of the system will be equal to the algebraic sum of all the charges present anywhere within the system. Now you can see I have made a cloud kind of. Now in this cloud we have different particles. The first particle is having a charge of +2 unit. The second one is having a charge of -3 unit, and the last one is having a charge of +1 unit. So what will be the total charge of the system? It will be equal to +2 -3 +1, that is equal to 0. So this is as per the additivity of charges. Now remember, here we are adding charges just like normal numbers. Okay, so basically as charges can be added like normal numbers, so charges are scalar quantities. So additivity of charges is true because charge is a scalar quantity. Okay, you have learned in the last class that if we have vectors, we cannot add directly, we have to use certain parallelogram law, triangle law, etc. So we don't need that for charges because charges are scalars. Now if you have such a system, like in this example we had the total charge is 0, then we will say that this system is electrically neutral or its overall charge is 0. So electrically neutral means that the amount of positive charge will be equal to the amount of negative charge within the system. Now if by chance it is not, say for example in this particular case is what it was say +2 -3 and -1. So what will happen? The overall charge will become 2 -3 and -1, that means it will become -2 unit, so it will not be 0. So whenever the overall charge is not 0, then we say that the system is charged or its charge is non-zero. Now property number 2, that is conservation of charge. So it's very simple that according to this principle of conservation of charge, the total charge of an isolated system of interacting particles always remains constant or remains conserved. What is the meaning? It means that suppose if you have different particles having different charges, they are interacting among themselves. So what will happen? Individually the charge of the particle or charge of the body may change, right? Charge of the system may change individually, but when we take the overall, okay, overall system comprising of all such particles, all such bodies, that overall system will have a constant charge no matter what happens to it. Whichever change is there, but the overall charge must remain constant. Okay, now for example you can see we have taken a simple example of a chemical reaction that you all are aware of, like we have sodium ion combining with chloride ion to form a sodium chloride molecule. So what was the total charge on the reactant side? That means before the reaction what was the total charge? It was +1 unit, some unit was there, and -1 unit. Okay, so total was 0. And what is the total final charge? Total final charge is also 0 because you know that a molecule is electrically neutral, you have learned in chemistry. So you can see the total initial charge and the total final charge of the system is 0, right? That means whatever happened, okay, there was sodium ion, there was chloride ion, they combined, they fused together to form sodium chloride. Okay, characteristics have changed, there is a change occurring, but the total charge before the change and after the change remained the same. So this is what is known as conservation of charge, and it is a universal conservation principle. That means no such process is possible which violates this law. So everywhere the conservation of charge must be satisfied. Okay, now coming to the important one, this is called the quantization of charge. Okay, so as you can see, whenever we use this term quantization, quantum, okay, it's something very interesting, right? So what is the meaning of quantization of charge? Now see, the property of quantization is basically linked to any object or any quantity whenever that quantity cannot take any value, okay, or whenever it has only certain allowed values or it has certain discrete values which the quantity can take, right? So quantization of charge means that the charge of any body or any free particle must be an integral multiple, or you can say integer multiple of a basic unit of charge, and this basic unit is represented as E, small e, and it represents the magnitude of charge of an electron or a proton, and that is how much? 1.6 into 10 to the power minus 19 coulomb. Here you know, you have learned in class 10 that coulomb is the SI unit of charge, right? So whenever we have any body, okay, any object, it must have a charge which is some integer multiple, okay, of the charge E. So we can have charge of 1 E, we can have minus 2 E, we can have 100 E, we can have minus 1000 E, but we cannot have 1.5 E, we cannot have 4.26 E. Why? Because 1.5 and 4.26 are not integers, right? So whatever is the whatever number is multiplied with E, it can be positive, can be negative, because charges can be positive or negative both, but it must be an integer. So this is what is known as quantization of charge. So basically what it does is it puts a fundamental restriction on the values of charge. So what it means that the charge for body can have only certain defined values, okay, it cannot take up any random value as such, okay. Now how we can explain this? It's very simple. Now you can see, you have learned about atoms, okay, in class 11 in chemistry as well. So whenever we have atom, we have some positive charge inside it and some electrons which carry negative charge, okay. So total charge of the atom is 0. Now suppose, say, you know the example, last example we took, sodium ion. So you know that sodium has how many what is the valency, what is the this one atomic number? 11. So there is only one valence electron. If it loses that one valence electron, right, so how many electrons will remain? 10. But how many protons are there in the nucleus? 11 only, because atomic number is 11. So what is the total charge now? It will be plus 11E minus 10E, that is equal to plus E. So whenever it lost an electron, it got positive charge. Same way, if it adds up electrons, it will become negatively charged. So it is obvious that the losing of charge or gaining of charge, or say acquiring positive or negative charges, is by what? Transfer of electrons, loss of electrons, or gain of electrons, So that is why whenever the body will get charged, it will basically say lose some electrons or gain some electrons. So obviously it is very much essential that the charge must be some integer multiple of electronic charge only, because obviously we cannot lose or gain electrons in fractions. The problem is that when we deal with macroscopic scale, like suppose the charge of a body is 1 microcoulomb, or say a few microcoulomb. Microcoulomb means how much? 10 to the power minus 6 coulomb. But what is the charge of an electron? It is 10 to the power minus 19 coulomb approximately. So if a body has say plus 1 microcoulomb charge, it has already lost how many electrons? So it will be plus 1 10 to the power minus 6 by 1.6 into 10 to the power minus 19. So around 10 to the power say 13 electrons it has already lost, right? Now if it loses 1 electron more or 10 electrons more, okay, how much will the charge change? The charge will change only by 10 to the power minus 19 or minus 18, okay, which is not a significant change, because if you add with microcoulomb, the result will remain as the initial result only. So what happens whenever we are dealing with macroscopic scale, the body has a few microcoulomb charges or more, what happens? The addition or removal of few electrons doesn't matter. It seems that the charge remains as it is without any change. So here the quantization of charge can be ignored, because here the change in the charge in steps of E is not very much visible. You can understand this concept by taking the analogy of an line. What happens if you put a number of dots on a piece of paper? Okay, it gives you a line segment, right? So basically a line segment is made up of large number of dots. So if I take out one dot from that, does it affect the length of the line segment? Obviously no, it remains all the same. Okay, so the quantization of charge is also here, you can compare it with the same principle. right? So quantization is true everywhere, but we can ignore it at the macroscopic scale, because in this scale the fact that the charge is increasing or decreasing in steps of e, small e, is not very much visible, right? Now coming to the last one, that is relativistic invariance of charge. That means what? That whether the charge is at rest or it is moving with some velocity with respect to u, doesn't matter, the value of the charge will remain independent of that. So this is called relativistic invariance of charge, right? But remember, this is not true for mass. Okay, if you remember, if you have learned earlier also, that when a body moves with a very high speed, its mass changes, this Einstein's relativistic formula, right? But that does not happen in case of charge. Charge will remain invariant whether it is at rest with respect to u or it is moving with respect to you. Although its effect will change. If the charge is at rest with respect to you, it will create something called electric field. If it is moving, it can create magnetic field. If it is in acceleration, it can create electromagnetic waves. Okay, that part we'll learn later, but right now you just have to remember that if the charge is at rest or if it is moving with some velocity, it doesn't affect the value of the charge. That was all about the basic properties of charges. Okay, how we measure charge, how we can relate the charge of a body with the charge of electron, etc., etc. Okay, now we are coming to the next part, that is how we can charge a body. Okay, how to charge a body or how to electrify a body. Remember, here we are dealing with macroscopic systems. Okay, so I can ask you how you will charge a glass rod, I can ask you how you will charge an atom, but I cannot ask you how you will charge an electron. Why the charge of the electron is negative? You cannot ask this question. Just in the way you cannot ask that why the mass of electron is 9.1 to the minus 31 kg. So the charge of any particle, when we talk about, that is basically intrinsic property, right? It is inherent. Okay, we don't know why it was such, okay, so far, but why the charge of sodium ion is plus 1 e, that we can explain. So here we are learning about how to explain the charge acquired by macroscopic systems, okay, which involve, say, more than one electrons at least. So we have different methods of charging. The most common ones which we'll be using, the first one is called charging by friction. Okay, it's very obvious that here we have to rub the things together because friction is involved. Next we have charging by conduction. That means when we are putting the conductors, charged conductors into contact. And then we have charging by induction, which is something new. Now you have learned in class 10th about electromagnetic induction. Here it is something different. This is called electrostatic induction. So first we are starting with what is called charging by friction. Okay, so in this we have to rub the surfaces together, like we have discussed earlier, that when we rub a glass rod with a piece of silk cloth, both of them get charged, right? So this is the exact mechanism we are learning here. So what happens here is, when we are rubbing the two surfaces, you know that while rubbing, okay, when we are trying to rub, friction will come into play. This friction will try to oppose the relative motion. So we are doing some work against the friction. Due to this work, what happens? Some heat dissipation will occur. The substances will absorb some energy. Now, due to this energy absorbed, what will happen? The electrons which were loosely bound, okay, valence electrons, some of them or few of them, it may happen that they leave the particular object, okay, and in the opposite one, okay, like if you are rubbing glass with silk, so we learned that glass becomes positively charged. So what we can say, that from glass electrons escaped out and these electrons entered into the piece of silk cloth. So the object which loses electrons will become what? Positively charged, because electron is negative and overall charge initially was 0, and the object on which the electrons have been added will become negatively charged, right? So whenever we charge by friction, what happens? Out of the two, one will become positively charged, the other one become negatively charged by the same amount. So both of them will acquire equal and opposite charges. Now here you can see the third point which I have highlighted here. The transfer of electron takes place from the body having lower work function that having higher work function. So what is work function? Now you know electrons are basically held within the atom, right? So if you want to take the electrons out, you have to do some work, you have to supply some energy. So the minimum energy that has to be supplied in order for the electron to escape out, that is known as work function. So electron will escape out of which material? Which has lower work function. Why? Because it was loosely held there. So it will be readily escaping out of it, and in the other one it will just get added. So you can obviously say that the substance which has lower work function, we need to supply less amount of energy in order for the electrons to escape. So electrons will move out of that material and added into the other one. Okay, so this is the point you have to remember, that whenever we charge by friction, number one, the two objects will acquire equal and opposite charges, and number two, the transfer of electrons will happen from the body having lower work function to that having the higher work function. Okay, now how much electron or how much charge will be transferred, that depends upon the materials, because already we said work function, it is a property of the materials, right? Now the problem is, generally we use this method for insulators. It works very well, but you cannot charge a metal rod. Suppose if you have a copper rod in hand, if you rub it with a piece of wool, you cannot charge in that way. Why? Because you know that earth is a good conductor. Okay, earthing you have learned in class 10th as well. Our body is fairly conducting as well. So what happens is, if you are holding the conductor and rubbing it, even though some charges will appear, what will happen? Due to the motion of the free electrons, because you know copper is a conductor, what will happen? The free electrons will move through our body to the ground, and this way the charges will be neutralized. So we cannot charge a metal object by holding in hand directly. You can charge it provided you have some insulating hand, okay, or your body is insulated from the earth, then it can be done. Okay, so you can see in the image very clearly that when the rod is rubbed against the piece of cloth, initially both of them were having equal positive and negative charges, both of them were neutral. Now the rag becomes positive and the pipe becomes negative. Why? Because the electrons were transferred from the rag to the pipe. So which one has higher work function? I can say the pipe has higher work function. Which one has lower work function? The rag has lower work function. Okay, but remember, the overall charge initially and the overall charge finally remains the same. Why? Because we know charges are always conserved. Now the next one, we have charging by conduction, right? So here we are putting one charged conductor to a neutral conductor, in contact to a neutral conductor, or we can say we are joining two oppositely charged conductors, or one is having more charge, one is having less charge, whatever we can do. Okay, so number one, it requires a physical contact. Physical contact means you can put the two conductors directly or you can touch them directly, number one. Number two, you can connect them by a wire also, conducting wire, because you know conductors facilitate the flow of charges. Through conductors, charges can flow, that you have learned in earlier classes, right? Now what will happen whenever the two bodies will be brought into contact? Okay, maybe one has more charge, one has less charge, or one is having charge, one is neutral. So now the total charge will spread out. Okay, it will try to occupy both the conductors, right? Now when these charges are spreading out, okay, it will happen because of the flow of free electrons, right? You can explain that by the concept of repulsion between the charges as well. Now the flow of electrons or the flow of charges will happen, it will continue as long as there is a potential difference in the electrical potential. It is somewhat like if you have water in a tank, okay, and there is another tank connected to it which is empty. So what will happen? The flow of water will happen as long as the two levels are different. Whenever the two levels will become equal, what will happen? The flow of water will stop. Same way, when the two potentials will become equal, the flow of charges will also stop. Now finally what will happen? Both of them will acquire the same type of charge. Either both will be positive or both will be negative. So whenever we are learning charging by conduction, the important point is the flow of charges takes place as long as there is a difference in the electrical potential, number one. Number two, the total initial charge remains same as the total final charge. And number three, both the objects will acquire the same polarity of charge. The quantities may vary, but the value will be, or the sign will be same, right? Now in general, remember that the term potential depends on the geometry of the conductor also. So it is not both of them will acquire the same value of charge also, right? But if they are of the same geometry, if they are of the identical shape and size, then what will happen? The total charge will be divided equally. So if I have suppose one object having charge plus q, the other one was 0. So if they are identical, it will be shared as q by 2 and q by 2. So both will have the same charge and the same sign, provided they are identical. Okay, So in general, we can say that if we have two spherical bodies, especially spherical I am mentioning because the formula is valid only for spherical. Initial charges were Q1, Q2. Out of them, one may be positive, one may be negative, both may be positive, or one may be something, one may be zero, whatever. And the radii are R1 and R2, and the final charges are Q1 dash, Q2 dash. Then what will happen? Q1 plus Q2 will be equal to Q1 dash plus Q2 dash. Why? Because charge is conserved and the potential will be equal. So this is the formula we get from the equality of potential, that is Q1 dash by R1 will be equal to Q2 dash by R2. Now the last one is charging by electrostatic induction. Now you learned in the last part that in conduction what was happening? One was gaining charge, one was losing charge. But is it possible that I will charge one object but the other one will not lose any charge of its own? So that method is known as the method of electrostatic induction. Remember, basically induction is just the process of redistribution of charges, right? Now if you see this image here, GIF image which I have included here, when the negatively charged rod is brought in front of the conducting sphere, what is happening? Due to repulsion between the negative charge of the rod and negatively charged electrons, the electrons are moving away. So what is happening? One part of the sphere is becoming negative because electrons are crowded there, and the other part where the electrons are not present in large quantity, it is becoming positive. Okay, so it is not that the whole charge will move from one place to another, okay, but there will be distribution of charges. Okay, so if I take away the rod now, it will again come back to the same initial position. So how will I charge the object, right? So for that you have to see the next image carefully. What will happen? First, I have brought the negatively charged rod. That created a redistribution of charges. Okay, the negatively charged electrons are moving away from the rod. Okay, now I am just grounding, earthing the second surface of the conductor. So due to earthing, what will happen? Some of these electrons will go down to the earth. Not all, remember. Why? Because all will not go, because the positive charges will be holding them. So when some of the electrons to the ground, obviously the total number of electrons will decrease. Earlier it was more, now it will be less. So as the electrons will decrease in number, what will happen? The overall charge of the conductor will become positive, and after that what we will do, we will just cut the grounding and we will remove the rod. So what will happen now? The total excess positive charge will redistribute and the sphere will become positive. So remember, only induction will not result into charging. For charging by induction, we must incorporate some third agent, like here grounding was the third agent. Is that clear? So that is how we can charge a body by the help of electrostatic induction. So induction, what happens? In induction, the type of charge induced will be negative. Number one means opposite to the first one, number one. Number two, what will happen? The first one is not losing any charge of its own, but the second one is gaining by some charge, but with the help of the third agent, which is the case of grounding in this case. Is that clear? Same way, suppose if you keep two identical spheres in contact and you put the rod in front of them, what will happen? The first sphere will become positive, the second sphere will become negative by the same mechanism. So you can just think it of as an exercise and try to solve it, right? So remember the basic points of electrostatic induction. Number one, under the presence of the charged body, redistribution of charges will occur. Number one. Number two, when we do earthing, some of the charges will be neutralized and the body will develop a net charge of the opposite kind. Now this was true for conductors, okay, but if the second body, like the sphere, was not a conductor but an insulator, like if it was made of paper or glass, what will happen then? Because in insulators we don't have free electrons, okay, so now the charges will not move, but due to the force of attraction and force of repulsion, there will be a slight deformation. Okay, slightly the positive charge will try to move towards the rod and the negative charge will move away from the rod. So there will be a deformation of the molecule. A part of it will become positive, a part of or atom, a part of it will become positive, a part of it will become negative. This is called polarization. We'll talk about it in the second chapter basically. So due to this polarization, the substance will become polarized and the polarized substance will experience a net towards the rod and it will get attracted. This is what exactly happens in case of the plastic comb or plastic rod and the bits of paper. So the basic mechanism for this we'll learn about in the next part, right? But remember that it is related to the process of induction somehow. So far we have discussed about what is charge, how to measure charge, basic properties of charges, etc., methods of charging. Now we are coming to the last point of this discussion, that is about gold leaf electroscope. So what is an electroscope? Basically it is a device used to detect the presence of charge and type of charge, means whether the charge is positive or negative. With slight modifications you can measure the amount of charge also. Okay, that is not a point of discussion right now. So basically we will discuss about a simple arrangement called gold leaf electroscope that you can make easily also. You can take it as a project also, very simple. Now what is it? Basically we have a insulated container like glass is used so that the system is not disturbed by flow of air or other things, right? Now this glass jar has a conducting rod. You can see it is made of brass. You can take copper also, and this brass rod has a disc. This disc is optional, it is not mandatory anyways. Okay, so we have a brass disc, conducting disc connected to a conducting rod, and at the end of the rod we have two thin foils made of gold. You can take aluminium also. Basically it has to be very thin, so we are choosing the malleable metals, right? Now what will happen? So whenever I bring a charged object like a charged rod near the disk, you just have learned due to induction charges will appear in front, like the electrons will be attracted towards or away from the rod and charges will appear on the disk. Or if you put the rod into contact, then also charges will flow. So if you bring the charged object near it or touch the disk with some charged object, happen, charges will appear on the disk. Now as the disk is a conductor and connected to another conducting rod, what will happen? These charges will flow to the gold leaves. Now both the gold leaves are conductors, and as they are joined together, so what will happen? Both of them will acquire the same kind of charge due to conduction. Okay, that you learned in the last segment. So as they have like charges, now what will happen? We have learned already like charges repel each other. So due to repulsion, the gold leaves will diverge. So very simple point. You can see the highlighted point here. Whenever a charged body is placed near or in contact with the brass disc of the electroscope, what will happen? Simply the gold leaves will diverge. So if the gold leaves are diverging, we can be sure that there is the presence of charge, right? Now this step is known as the step of charging of the electroscope, right? So that is how we can understand whether the object is charged or not. Simple. Now the question is how to understand whether it is positively charged or charged. So for that we have to use two steps. Firstly, suppose I know that the first rod, glass rod, was positive. So when I touch it, the leaves get diverged, right? Now if I bring in another positive rod, I don't know whether it is positive or negative, but if I bring in, what will happen? The disc will become more positive. So the divergence between the gold leaves will increase. And by chance if I bring a negative charge, what will happen? It will become less positive. That means the divergence will also decrease. Okay, so by using the second step, first we will charge the electroscope, and then if you bring the second one, unknown one, and if you see that the leaves are more, that means the charge in the second object is same type, means either positive or negative of the initial one, and if the divergence decreases, that means it is of the opposite type. Now the last part, why this metal foil is used. Now see, this metal foil has been earthed. So if there is some charge coming onto the gold leaves, by induction the metal foil will acquire opposite charge because it is earthed, you can see. So what will happen? Positive and negative will attract each other and the divergence will increase further. So by using a very small charge on the electroscope also, the divergence can be large. So it will help us to discharge easily. So that is why the metal foil is used to increase the sensitivity of the electroscope, right? So here we end with our discussion. So whatever we have learned, these were regarding the basic introductory part, meaning of charge, types of charge, how to charge an object, what is the use of electroscope, and so on. Okay, so please you can go through the text, okay, and you can read out the text, follow the examples to understand the concept well, right? In the next class we will learn about the very important part of this chapter, which is called Coulomb's law, and we'll discuss about the other points like how to measure the force between two charged particles, okay, what is the meaning of electric field, etc. So thank you so much, and we'll again meet in the next session. Thank you.